All right, we're getting ready to start the last lesson of this unit as far as how to factor different types of polynomials. Today has a formula, and the formula makes it very easy to follow. You will be given the formula on the test. So if you can follow through with the formula, you'll have no problems factoring these polynomials. This is called factoring sum and difference of cubes. Cubes means to the third degree, or it is a number that has been raised to the power of 3. So we do what is called cube rooting, and we'll be able to do the cube root on your calculator. All right, so just had to grab a calculator real quick. So now then, when you're working with writing and with the sum or difference of cubes, there's only going to be two terms, and they can be plus or minus. Okay, when we were doing the difference of two perfect squares, that rule we could only do subtraction. But cubes are a little different. You can use addition or subtraction. I want you to write the formulas up here at the very top of your paper. All right, the first formula is this. If you have the sum of two cubes, a cubed plus b cubed, your factor will look like this. You will take the cube root of a, which is a, the cube root of b, which is b. Those will be added together. But then there's a lot more, okay, because these are to the third power, so it's a much bigger, it's going to have bigger factors. You take the square root, or a squared, plus, I'm sorry, not plus, make that a minus a times b plus b squared. So what we have to do is find the cube root of a. So that's super important, and I'm going to show you how to do it on the assignment. Then if we have the difference of cubes, the formula will look like this once it's factored. A minus b, parentheses, a squared plus a times b plus b squared. So both of these have a minus sign somewhere in them. But this difference formula has it in the binomial factor. The positive cube has it in the trinomial factor. So it's just located in a different place, but that's the only thing different about these formulas. So it's really important you have them written down in front of you so that you can find them very easily. So we're going to need to be able to find the cube root of a cubed, which is a, and the cube root of b cubed, which is b. And on the calculator, I will show you how to do that. So let's flip over and look at the back page. All right, again, I'm going to write these formulas down. I'm going to mark out number 13 and 14. I'm not using a separate notes page because the notes can be very simply done right here. Okay, so let's review the rule again. The rule is if you have the sum of two cubes, the formula is the cube root, a plus b, times a squared minus a times b, minus a times b, I didn't need to put that there, plus b squared. There we go. I don't have any, yep, I do have some white out for that. Hopefully y'all didn't copy me on that. Then your difference of cubes, if you have a subtraction sign between them, will be a minus b times a squared plus ab plus b squared. All right, so using this formula, first thing I want you to do, first identify A and B. Identify A and B. So find your cube roots. So right here, this is my first term, 3x to the third plus 24. Well, 3 is not a perfect cube. Okay? If we were to take our calculator, and this is where you find your cube root, hit your math button right below the green alpha key. If you look at number 4, you can either hit the number 4 or arrow down to the cube root, hit enter, and it will automatically put it in your calculator for you. If you were to type in 3, you would get an irrational number. It is not a perfect cube. A perfect cube is a number that's been taken to the third power. So for example, if you've got 2 cubed, that's 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. So if I were to ask you what the root, the cube root is for 8, I want to know this number. The base number is what I'm looking for. That was taken to the third power, and that is 2. And if I wanted to know the cube root of 27, that is 3. And if I were to put the cube root in my calculator, math, go, oops, and I didn't want to go up. There we go, right here. And if I were to type in 27, I would get the root of 3. Okay, well, these aren't perfect cubes, but they do have a greatest common factor. So the first thing before you ever get started is check for a GCF. Check for a GCF every single time you're getting ready to factor. All right, we do have a common factor. It is 3. So I've got 3 times x cubed plus 8. Okay, now, this is now the sum of 2 cubes. X to the third is a perfect cube because anything to the third power is being cubed. And 8 is a perfect cube. So my A value, if I were to take the cube root of x to the third, I would get x. And B, if I were to take the cube root of 8, I would get 2. So if you wanted to write down x to the third and we take our cube root, that would be x. That's probably a better way to do it, just so you can see what we did to get our cube root. So now, everywhere I see an A, I'm putting an x. Everywhere I see a B, I'm putting a 2. And if you can do that, then you're golden. So this is the rule we're going to follow because it's sum. All right, so we've got this 3 outside of the parenthesis. All right, so what goes in here? A plus B, x plus 2. So I'm going to put x plus 2. Then we have a squared. Well, what is a squared? That would be this number squared. So that's x squared minus a times b. A times b, that's 2x. Plus b squared. What is b squared? It's 4. I have factored the sum of 2 cubes. All right, let's look at the next one. The next one, it also has a common factor. All right, Sometimes you have a common factor, sometimes you don't. It's just like any other polynomial. So this common factor is 3. And if I were to factor out a 3 of each term, I would be left with an m to the third minus 216. Well, off the top of your head, you may not know what the cube root of 216 is. So what we're going to do is we're going to find it. Put your cube root in there. Type in 216, not a negative 216, just 216. Don't put the sign in there with it, just the number. It is 6, because if we were to take 6 to the power of 3, we would get 216. So our cube root is 6. All right, so now we've got our a value is the cube root of m to the third, which is m, and our b value is the cube root of 216, which is 6. So these are the values we're going to be using in our difference of two cubes. So this is the formula right here. So this 3, remember, was our greatest common factor. We took that out. This is going to be our binomial right here. A minus B, A minus B, M minus 6. This one is A squared, so that's your M, plus A times B, plus 6M, plus B squared. That's my 6 squared, so that's 36. And these are my factors. Now, some of you may be wondering how this huge thing multiplies to this. Well, if we were to multiply all of this out, we would have terms that cancel each other out. Our m squared would end up canceling out. Our 6m, our m value would end up canceling out because we multiply across here and we get this is a negative 36m and this is a positive 36m, and those are going to be canceled out. So what you have left is this expression right here, which is your 2 cubes. Okay? And that's it. You've got your addition and you've got your subtraction. You are going to do the front page, numbers 1 through 10, number 1 through 10 only, just to practice this formula, plugging them in. So remember, first thing, do you have a common factor? No. Identify your cubes. So I'll start the first one for you. This A, we want the cube root of 27. This next one, for our B, we want the cube root of 8a to the third. Now, we know the cube root of a to the third is a. The cube root of 8 we can actually put in the calculator, and that's 2. The cube root of 27 is 3. So remember, your cube root of your variable is just going to be the base. Okay? Get started on 1 through 10.